My name is Austin Curtis. I'm a maintenance manager for Portland General Electric. I'm here to share with you today a implementation of vibration monitoring that we put on our critical assets, and then how we use Pi to link up our vibration signals, and how we're able to analyze data live from anywhere in the world. With me, I got Steve. And he's a representative from BK Vibro, and then also Ken Kubo here, who was the champion for the project itself. So this is my first time at Pi World, and excited to be here. I still haven't seen a single slice of apple, peach, or cherry yet, so I'm going to look for that later. So before I jump in, I want to tell you a little bit about Portland General Electric. So we're a vertically integrated utility, publicly traded, regulated. We serve about 885,000 customers in the Portland-Salem area, surrounding communities, about 2,900 employees. I'm going to focus today on our gas-fired plant, and most specifically here, Beaver, where we implemented this project. So got kind of an example of our portfolio of how we generate and meet load demands day in, day out. So Beaver Generating Plant, it's a 6-on-1 combined cycle plant. There's 7 Bs that feed into a single steam turbine. It's a 155 megawatt steam turbine. And then we also have a little red-headed stepchild out there. It's an Alstom simple cycle for super peak. The plant itself is a peaking facility, and so there's a lot of maintenance challenges associated with that, and it's critical that the plant itself is ready to go in the third quarter when temperatures are really high and people are really hot and want to be cooled down. So the importance of the project here was knowing that I know the state of my machines and the health of my machines as we move into the third quarter, and just overall general health of the machine at any point in its operational times. So let's get to what you guys want to hear about. Where this project all started. It all started here back in 2015 when Ken reached out to Steve and said, hey, I saw this project. I think it's something we can implement. And from there, the project basically rolled out. And so what we did, how the project started, we basically had to do an assessment of what our machines were. As you can see there, we got a big hodgepodge of different data, right? So we had velocity and proximeters, and no CMS system, so no continuous monitoring. So I could never honestly tell you, yeah, is the machine going to be reliable, dependable? Maybe, right? So I didn't have a good vision of that. Here, if we want to, I'll have Steve kind of explain this.
One of the things we did for PGE before we got started with the project was made sure they had the right sensors. It's the old saying, if you have bad data, you can't do much of any value with it. So gas turbines from the OEMs, GE, Siemens, and others, are measured by putting sensors on the outside of the machine, as you can see over there. So the shaft rotates. It causes the machine to vibrate, and you infer what's happening on the inside of the machine by looking on the outside. It is good for what I'd call crude vibration measurements, but it doesn't tell you a lot of what you really need to know. And I'll have you advance. If we put proximity probes in the machine, now these are different than the casing sensors. They observe the shaft directly. And normally they're mounted 90 degrees apart in an XY configuration like you can see here. And if you'll advance again, Austin, can you see the little orbit that we have? It's the motion that the center of the shaft traces out. The proximity probes allow us to see that level of detail of what's happening in the vibration. The orbit, just to give you kind of an order of magnitude of what we're looking at, an orbit typically is 3 mils. So we're talking about the thickness of a human hair. These are tiny, tiny displacements on this turbo machinery, and it runs very fast. You know, these machines are rotating at 4,000, 5,000, 6,000 RPMs in some cases. So the vibration measured from the Y probe you can see in the upper left, and you can see that that vibration is below the alarm levels. But on the right, the X probe, you can see that vibration is above its alarm levels, and so we've colored that probe red. And it's just a simple way for you to kind of visualize how these sensors measure the vibration, set alarms on the machine so we can actually protect it if it vibrates too much. But it's that orbit pattern you can see there. That's what allows people like Austin to really drill down and see, is my machine healthy? Is it sick? If it's sick, what's wrong with it? And as we go through the presentation, you'll see how the data from these sensors goes into the Pi system, and then it's accessible to the people at the plant and everywhere else so they can start to do those detailed diagnostics.
Yep. So we'll talk a little bit about what the problems were. I had no online condition monitoring. If there was a vibration issue, it was always reactive. It was after the fact. I have to go out and set up an Audrey 408 and hope that I can get a repeatable set of data. I had no remote access. I had to manually go out, pull the data, send the data off via FTP site, or sometimes it would involve bringing on a data analyst. It could take 5 hours. It could be a flight. It just really depended on where they were and how important it was to get the machine up. It was just really slow. I had siloed data. So I have the vibration data here, and then I have my DCS and Pi data, and they just weren't talking to it. They wouldn't interface. It would be a lot of back and forth, overlaying, and just an arduous process. It's closed data. So basically, it's a software that I have to pay for licensing every year, and that hits my O&M budget. And if I can save some dollars somewhere else and spend it elsewhere on the machines, that's where I'd rather focus my money and attention. So lastly, it's really, I had no good picture of what my assets look like. There's no dashboards. There was no easy view into the different, I couldn't look at oil temperatures and the vibration, or could look at the startup. All that data was federated and not an integrated system. So it just took a very long time to get a good data analysis complete. So what do? Partnering with SETPOINT here, we basically added prox probes to our machines, and then from there the vibration sensors would talk to the SETPOINT system, and then from there the SETPOINT system would then be integrated into the Pi, and we can basically we can now get a total solution, a total picture of what everything looks like. And the main part here, what's really important for vibration analysis, is that you can actually get the waveforms, so you can do a full vibration analysis via the Pi. I don't know if there's anything else you'd like to add to that. All right. So this is where the state we are today. As you can tell, as you can see there, we got prox probes on every machine. We have SETPOINT as our main data collector, and then we have a continuous monitor that's basically through these SETPOINT racks. So what does this data enable? I can now understand and see everything that's going on in my plant. So we got the data that's all talking in a single database. I got remote access now, so I could be down in the urban tavern looking at my piece of pie that's somewhere around here, and I can log in right now, see what the machines are doing, look at waveforms, full spectrum analysis. I can do all this from a laptop from anywhere in the world as long as I have Wi-Fi. So what did it do? Well, we got integrated data. I don't have that vibration data that's siloed. I don't have a manual process anymore. It all just dumps via Pi. And I can now overlay and get my process data and my vibration data all in one. Another part here, I'll let Steve kind of cover this one here, but it's an open free software. So.
I remember vividly going to the Beaver plant, talking to them about this product before they purchased it. And one of the things that appealed to them, as I said, we've tried to build a system that works like Adobe. And you put the vibration data into your Pi system, but if you want to share it with other people and they don't have Pi or they don't, have easy access, you can literally send them a file format that we call CMS, Condition Monitoring Software. So it is a .cms file extension. You can email this to people. They can go to our website. They can download it just like you would Chrome or Safari or a browser. It's a viewer. You can download that, and it allows you to open and view these files. And a lot of times, if you come by our booth today, for example, and we show you how the system works, we'll be using one of those CMS files. You can play the data back like TiVo. You can do anything you want with it. And the beauty is that it's like Adobe. It's a free viewer that you can get from the website. So once the data comes out of the system and you want to share it with other people, you can do that. And that was a big thing for the folks at PGE, was that there were a lot of people that wanted to see this data and interact with it, and they could interact with it and view it just like they could a Adobe PDF file.
And what's great is it's always up to date. I have the latest and greatest viewer available to me. It's just a matter of emailing IT and saying, hey, I need the latest. And it's dropped into our share drives. So another great thing is I can send it to my analysts, our third-party analysts, and they don't have to sign up and get a licensing fee. So again, this takes O&M dollars out of my licensing fees and allows me to spend those dollars elsewhere on more important things for the plant. And so lastly, now I have a full picture of what my assets look like, what the plant looks like. I can go into the third quarter now and say, yeah, we're ready to go. Another thing that this has done for me is I've been able to switch from a time-based maintenance. So now I can look at and go off of I can make my maintenance plans based off condition-based monitoring with integrating of all the PI data, the DCS data, and the vibration data. And I can say, yeah, well, we can push this out another year based upon what I'm seeing, wheel space temperatures and spreads and so on and so forth. So I can make that decision, well-educated decision based upon what I'm seeing with SETPOINT and the PI data. What we want to do now is kind of go through some screens of what our stuff looks like. Ken's going to come here and speak through these screens. His team helped set up the screens and really championed this project all the way through completion. So.
Thank you, Austin. I am Ken Kubo from Portland General Electric. We work in a downtown group called the Remote Monitoring and Diagnostic Center, and so basically we support the plants. We monitor data, provide condition assessment on the equipment, and also look at thermal performance, and basically with the aid of trying to help Austin run his equipment better. When we first got SETPOINT, one of the first things that we did is we basically took the data Sorry about that. We take the data and we built some PI vision screens around it because, like we said, now that we had the data together, we wanted to be able to see the correlation between the process data, like lube oil temperature, bearing temperatures, and the vibration that's going on, so we could do diagnostics and try to determine if there was a root cause to maybe some of the vibration anomalies. So we built these tools to kind of look at and support and do that diagnostics. But then we realized that we really had a hard time finding out, like, when you look at this data, it's really kind of noisy. When should we be looking at this data? We don't want to look at it every time the unit runs. We really want to kind of manage by exceptions. And so one of the things we did, so now all the data is sitting inside of there. We have an advanced pattern recognition software suite. We can bring that data into that advanced pattern tool now that it's in PI, and we built some models that kind of monitor the model really well during standard operations, steady state operations, and that'll flags us to any vibration changes that go on in there. But it doesn't help us very much when we come to transitions. When we do startups and shutdowns, those advanced pattern recognition tools don't work very well. And so what we did is we went in and we built basically some PI-AF event frames to capture the starts and shutdowns so that we can compare directly the vibrations that happen that occur during those points. So when we drill into these, we start looking at the individual bearing vibration signatures, and we can kind of just say, hey, which one of these look different in here? And so when we drill in and we take a look in there, we had a period in our vibration data where the vibration was kind of low, and then there was after one particular one, there was a step increase, and that step increase changed in there. So now that we know that we have something that's different in the system, how do we go in and drill in and find that? And that's where the SETPOINT software comes in. So As it was stated before, it's really easy. I just grab the software, install it, put it on my machine, and then I can connect it to the Pi data. So the first thing that we do is, if you look in the upper left side over there, you can see that there's kind of a drill down into the assets. And this is actually based off a Pi-FF structure that's pushed out of the SETPOINT system into our AF databases. And it basically provides that context about which machine we're looking at, which bearings it is, and also some of the configurations around the SETPOINT system on that particular machine. So since it's in our AF structure, we can also use it to leverage it in our asset dashboards when we're displaying that information, so we can show that configuration. And you can also use it inside of the tool here to kind of navigate around and go to the particular asset that you're interested in and select the bearings that you want to go look in and drill down into that deeper analysis in the vibration spectrum. Once you've selected where you want to go, down in the bottom, there's a kind of a time event around over here. So the very bottom area is kind of the area of interest you're looking in, and you can grab that and you can expand it, and you can slide it around to say, this is kind of the vibration area that I want to go do my analysis inside of there. If you want to jump around, there's some, in the top menu, there's some areas where you can just kind of jump to a time date or anything, just kind of like very much similar to like Pi Vision or Process Book. Once you've selected that, then you have the ability to kind of look at the data both in the time waveform and the frequency waveform domains out there. So the typical tools that you would normally see in any vibration program are there, the orbits, the time series data, full spectrum, cascade plots, and stuff like that. And then the context of it is kind of like, if it's based on time, it's based on the lower screens in the area we're looking at in there. So this kind of provides us a look at how we can look at the vibration during normal runs, and then again, using tools like the Cascade, we can actually start looking at how that vibration signal changes as the unit comes on or offline. So there's also kind of the Boyd plot and the polar plots, which are basically the amplitude of the vibration and then the direction where that peak vibration happens after one of the probes, so that what they call phase inside of there. And it's a good tool for looking at the startups and saying, is my vibration consistent, and is the criticals on the machine, which is kind of the natural frequency of the vibration of the machine, is that being consistent, or is it shifting, which may indicate that I have a really severe problem with my rotor health. So when you take all this together, we have kind of the Pi side of it, using some other tools that help us go detect when the anomaly it is. And then once we found the anomaly, the SETPOINT gives you the tools that kind of dig into the different various operational modes to go determine what the root cause of that problem is.
So to kind of summarize things here, we had no online condition monitoring. We didn't have the data. We had the data, we just didn't have it put together in a single database. We're working with SETPOINT and BK Vibro, we're able to implement the SETPOINT racks, and now we have a full online condition monitoring where we've basically gotten rid of the two siloed data, and now we have a single dashboard available to us, to anybody in the company. And basically what we got to is we significantly reduced our risk in the third quarter, knowing that we have eight healthy machines ready to go. And we've also reduced the amount of time associated with data analysis. We can have a data analysis done within an hour, as opposed to in the past it could be up to 15 hours to a day while we wait for FTP sites and our vibration experts to look at the data. Now we have it at the touch of our readily available at our lab, in our laptops anywhere in the world. So that kind of concludes what we have to say today. Are there any questions?
Great job. So if you have any questions, please raise your hand and we can get a microphone to you.
David Martrana from Tenasca. I was curious, what did you guys do with your old Bentley system? And then, too, also curious about what you guys are doing with your BOP equipment, large pumps, fans, motors.
Yeah. So what's great about the SETPOINT is the SETPOINT system is it integrates with our Bentleys. So we had a Bentley system already put onto our steam turbine, and it just interfaces with that. And from there, we can pull waveforms into Pi, and we're able to they just talk together and link up, which is great because we don't have to basically buy additional items. Our BOP is done with a Scout Ascent round, so it's handheld, and then we're also looking at integrating some wireless technologies here this upcoming year. So.
Yeah, and on top of that, so on the boiler feed pumps, we're looking, once they go through another rebuild cycle, we're going to install prox probes, and then we'll actually bring it into that same SETPOINT system that's being used to monitor the steam turbine. So that's kind of the aim is on these critical assets. Because it's a peaking plant, it's really hard to sometimes get the vibration rounds in there. So we really want to go to that online condition monitoring so that we can catch any time the unit runs.
Hi, Mike Santucci, ECG. Just curious, in the time domain, I see you pulling off the X and Y signals. In the frequency domain, how many signals or bins are you pulling back and hysterizing in the Pi system? Thank you.
Pi tags are really good for time series data. So the waveform, if you want to, in 2017 in London, I did a talk about half an hour, and it explains how we put this high-speed data into Pi tags. So I encourage you to go on the OSI website and watch that if you're curious. How do these guys do that? How do they get this high-speed data in there? We store everything in the time domain, and when we need to show spectrum, we bring it out of the time domain, we do an FFT, and then we present it. So when you saw like the cascade spectrum plots, that's all post-processed. It builds very fast on the screen, maybe 2 seconds or so to build that up. And but Pi tags aren't real good at storing frequency domain data. If you had 1,000 line spectrum, you'd need 1,000 tags. So that's why we store the data in the time domain in a tag as opposed to the frequency domain.
Hi, it's Gus Carfrey from CS Energy. For us, it's what was the time frame for the implementation of the program, and what sort of effort and resources and cultural shift did it take the organisation to realise the value?
Yeah, so the project spanned was 2 years. What's taken the longest is getting the machines open, because you got to do a major overhaul in order to get the prox probes installed. So every one of the generators has proximity probes installed on it, and as we go through a major overhaul, we'll be adding the prox probe. But the installation of the racks themselves is a couple weeks, and it's the installation of the proximity probes that really took the longest portion. And then the culture shift is really we were able to show that we're getting good data analysis, and we have people in the downtown offices looking at the data and reaching out to the plant saying, hey, you guys might have an issue here. Hey, we saw a step change here. And so it's really the operations side of things has seen the benefits of it, because they know they have an additional set of eyes looking at the machines and looking out for them. And when you're in the noise of operating, you might not be able to pick up the small little things. And so when we have a downtown group, they're able to be that additional set of eyes and support us from an operations standpoint.
Hi, Todd Beavian with EDPR. So we, this is a BKV question, I guess. So we use VibraSuite to do vibration monitoring on our wind turbines, and we also have a Pi system for a lot of the other operational data. But as far as I know, I believe those two are siloed. So VibraSuite comes kind of all self-contained, and then we have all the Pi data. Is that something that we could still use the alerts and everything in VibraSuite, but have the data stored in Pi so we could easily integrate it with our other systems?
The SETPOINT product was acquired by Brunel & Kjær Vibro about 1.5 years ago. So as you'd expect, the VibraSuite approach to the world was developed by a group of people in Nerum, Denmark. And the SETPOINT approach was developed by some people not too far from here, Minden, Nevada. But as we've gotten together, as part of the same company now, we realize that there's a lot of things we have in common. And one of the big parts of our strategy is to leverage our relationship with OSIsoft more. So on the side of we call it our industrial side of the business, we rely very heavily on Pi. On the wind side, they didn't so much, but they're beginning to discover how valuable Pi is and how many wind customers are Pi users. So in the future from us, I think you're going to see tighter integration between our wind turbine solutions and Pi systems. We have many customers in the wind realm that say it is non-optional, you must connect to Pi, and as we begin to ask why, it's a lot of the same story that you saw here. They want to do advanced pattern recognition, they want to apply machine learning and artificial intelligence to that so they can do more than they're able to do with just human beings. So long answer, but the bottom line is, yes, you'll see more from us in terms of tight integration with the Pi system and being able to leverage your investment with Pi to get more out of it with vibration data.
Marian Dudek, Accenture. How did you ingest the data into data archive, and how much did you use the templates and asset framework structures in general?
The way the product is structured, it can't do anything without asset framework. So it's what gives context to the tags. And I think, as Austin mentioned, or Ken actually, asset framework is what tells you I'm on unit number 1, outboard bearing, X probe, 1X amplitude. So that's all asset frameworks. When you configure the piece of hardware you saw on one of those slides, all of that is in there. It knows what probe is connected to what bearing to what machine. And you don't have to rebuild that manually in AF. It's a very elegant system. You push a button, it pushes the configuration out of the instrument into your Pi AF thing. And even the OSIsoft people that have seen this thing work, their eyes get big because it's all automated. It just pushes the config up and boom, it's ready to go. So we rely very heavily on that. Alarms and things are done in event frames. And we're more and more starting to leverage even more of this Pi ecosystem in terms of getting the most out of it. It's been a really, really good choice for our business to choose to work with OSIsoft. It has helped us and not hindered us in terms of serving customers.
And I can't speak enough on how easy of a tool it is to use. I had no formal training in it, and I was able to navigate around. It's literally a click, drag, drop type setup, so it's extremely user friendly. And I mean, I sit down with my techs, and in a matter of 5 minutes, they're navigating through the screens and understanding what they're looking at, and it's not clunky. It's a really elegant system and user friendly.
Any other questions?
Out of curiosity, what kind of APR software do you use?
We use the Curtiss-Wright famous suite, so PDP.
Hi, Mitch Radzine from Minnesota Power. So for companies who don't have AF structures set up, is that something that you're able to build just an AF structure for the set point side of things?
Unfortunately, the AF is essential. We can't do what we do. Now, if you think about vibration data in really 2 broad groups, you have what we call static data. That would be the alarms and the overall trends and things. You can bring those into Pi just like you could from any other system. So any vibration monitor in the world, you could connect a Modbus interface and stream in and trend the data. What really sets this solution apart is it can bring in that high-speed waveform data. So as you're looking at trends and alarms and things in Pi, as you saw, you might reach a point where you want to drill down. All the underlying data is in the Pi system, but as soon as you want to drill down to the level of seeing an orbit, a spectrum, a waveform, a polar plot, a Bode plot, a shaft centerline plot, all these specialty tools that the machinery diagnostics people use, that's the point you're kind of stepping out of a Pi visualization environment and moving into the SETPOINT visualization tool. And in order for that visualization tool to do what it does need to have that AF framework behind it.
Excellent.
Any other questions?
All right. Thank you, guys. Great talk.